Hi, and welcome to Mr. Douglas's Math Channel. The table is set for us to learn about ratios and tables. Yes, that was a very bad math joke, but trust me, this lesson will be much better than that. Are you ready? Here we go. Today we're looking at ratio, wait for it, tables. And while this is the classic lesson on ratio tables, I want for you to think about this as we're looking at increasing or decreasing quantities. So we're going to kick this off with an example. But first, I've gotten some requests. I always get excited when I get emails about more puppy dogs. As most of you all know, I'm a big fan of dogs. I like dogs. I like dogs a little bit more than cats, I'm going to be honest. I like the dogs. I've always had a dog. So here's another doggy. And this drawing was actually inspired by a dog drawing that I saw while I was in Taiwan, actually. And I thought it was a really cute way to do a dog. So there's some, then we'll color these in. Should it be a crazy dog? Should you make it crazy eyes? Sure. Like it's got red eyes. Maybe it's like a vampire dog. Can you imagine if there were vampire dogs running around? And there's his tongue. There we go. And the dog's pretty happy. He's like, there we go. So the doggy's happy, and he wants to go and help us out. So he's gonna go and help us out today. All my dogs are always like little blocks like that. Give him a fairy tale. Look up. Okay, so anyways, he's going to help us. Kind of looks kind of crazy. So we're looking at increasing and decreasing quantities. So let's just imagine that we're talking about, I don't know, lightsabers. So we got lightsabers. And let's just go Sith. So you got a red lightsaber. So here is should we make it a Kylo? Sure, why not? There's Kylo Ren's lightsaber. Okay, so there's Kylo Ren's. And then not the original Luke, but episode 6 Luke. So there's his green lightsaber, which is the best lightsaber of them all. Okay, so we're talking about lightsabers. And let's see if I can do this. That's not very good. Ooh, well, is that going to cut everything? No, that's not going to cut everything. Let's go and try this again. Oops. Nope. This will work. I don't want to do that either. Okay, you're keeping your faith. There we go. That's awesome. And I want to paste that. Oops. I don't want to make it bigger. So there's one. I need another one. This is faster. Maybe not. Oh, whoa. Okay, so we got 3. I like that. That's good enough for me. Okay, so we got 3 Lukes and we got 1 Kylo. So what would you say the ratio of the red lightsabers to the green lightsabers? If you had to go and say what are the ratio, you would say the ratio is 1 to 3. The order matters. If I had said what's the ratio of the green to red, you would have said 3 to 1. So the order does matter. That's pretty important. Okay, but here we go. So for every one Kylo, there are 3 Luke lightsabers. But here's my question. What happens if all of a sudden, so here's my question. This is the focus of today. So ratios are keeping everything equivalent. So we're talking about equivalent, which means equal, right? Equivalent ratios. So keeping things in ratio. What would happen if we increased Kylo to, let's say, 3 red lightsabers. If you wanted to keep equivalent ratios, what would happen if all of a sudden there were 3 of these? What would happen to our green lightsabers? Because if we want to keep ratios equivalent, we just can't go and add 3 red ones or make these to 3. We have to also increase the green. So what would happen? Well, this is where we're going to use ratio tables. Bum, 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 bum. So here we go. So where's my ratio table? So here's my table. And what were we talking about? We're talking about, I'm just going to use red ones and green ones. I'm not going to go and draw. And originally you said it was 1 to 3, right? But I said, what would happen if I increase my reds to 3? Well, I want you to think about this. How did that happen, actually? So how did that happen? How did 1 become 3? So how did 1 become 3? And I always want you to be thinking about multiplying. So multiplying or dividing. Okay, so how did it happen? Now, I think you're probably saying, oh, I went 1 times 3. Yes, you went 1 times 3. So here's basically the rule then. If you went 1 times 3, which you did, right? You went timesing this by 3. Then down here you need to times this one by 3 to make sure the force is balanced. Did you see where I was going with this? So it makes everything balanced. So what's 3 times 3? So there's 9. So with ratio tables, you're keeping everything equivalent, and you're showing as this increases, this one also increases. Now ratio tables can also work the other way as well. So ratio tables can also work the other way, and the other way would be decreasing. So let's just keep up with the theme of lightsabers, okay? So we got red, and we've got green ones. And let's just say we started out, and there were, I don't know, another situation. There was 80 red lightsabers, so there's lots of Sith running around, and there's more good guys, right? I hope so. And there were 100 green ones. But then all of a sudden, they became 40. So you have to ask yourself, how? How did 80 become 40? And think of multiplying or dividing. So how did it go from 80 to 40? Well, hopefully, you're thinking like, oh, did we just go and divide by 2? Did we go and divide by 2? You did. So you can go the other way, right? So 100 divided by 2, so there would be 50. Now, so what does that all mean? Remember, we're talking about equivalent ratios. So let's just write it down, see what it actually looks like. So I started out with an 80 over 100, and I said that's equal to 40 over 50. Is that true? Is it? Well, absolutely it is. It definitely is. There's different ways to prove it. To prove equivalent ratios, the way that I personally like to do it, it might be a little bit too complicated right now, but I like to cross multiply a lot to see if they actually are. So what's 100 times 40? Well, that's 100 times 40. That's going to be 4,000. And what's 80 times 50? Oh my gosh, that is going to be 4,000 as well. So those are definitely going to be equivalent. Hey, let's go back to our very first question way over here, right? Way over here. I said 1 to 3 is equal to 3 to 9, didn't I? Well, is that true? Let's just try and just do our cross multiplying. What's 1 times 9? 9. What's 3 times 3? 9. Yes. Boom. They are equivalent ratios. So this is using ratio tables. Now, you're asking like, oh, I got that. No problem. Well, let's just kick it up one more notch. Let's go for the crazy question, okay? Here's the crazy question. So the crazy question is going to require some problem solving on your part. Let's go with some different colors of lightsabers, shall we? Should we go Mace Windu? Some of you are like, what? How did I get a teacher that loves Star Wars? Okay, we're gonna go Mace Windu. So we're talking about purples. And let's go Obi-Wan. So we're gonna go blue. So there we go. Now here's the thing. I'm gonna tell you there are 3 purples. So there are 3 purples for every 4 blue. For every 4 blue. That's the ratio. So how would you write that as a ratio? You would write it as 3 to 4. Absolutely. 3 purples to 4 blue. Don't forget, if I said, what is the ratio of blue to purple, you would write it as 4 to 3. The order matters. But we're just going to say 3 to 4. Purple to blue. But I'm going to ask you the following question. What if there were 10 blue? What if there were 10 blue? What if? Okay, let's go fill out our table. And we'll use the fun color of green. I like green. So originally it was 3 to 4. And I want to know, I'm going to do this on purpose right now. What if there was 10? 10 blue. Okay, here's your problem solving. I need to get 4. I need to get 4 to become 10 in a very easy way. What's an easy way? So for some of you, you might be saying like, oh, well, what if you just multiplied by, I don't know, 2.5? Okay, maybe you can see that if you multiply by 2.5, you would get there. What's 4? Let's just kind of prove that. 4 times 2.5. So I think that would be 10. Yep. And then what would 3 times 2.5 be? That'd be 7.5. What? You can have half a lightsaber? Yes, in this scenario you could. Okay. But there's another way you can do it as well. I'm going to show a tricky way. So this is the tricky way. Let's see if you guys can bear with me. It's going to take a couple of steps. Because I don't want to use decimals, because decimals sometimes scare people. What if I went and just divided by 2 right now? What? Divided by 2? What's 4 divided by 2? Well, that's just 2. What's 3 divided by 2? Well, that would be 3 over 2, or 1.5. Now I'll show up. How do you get from 2 to 10? From 2 to 10, you would multiply by 5. So I'm just kind of working my way through this ratio table. And if you had to do this, this would become 15 over 2. But we like to keep ratios to 1. So I would say that would be 7.5. So in reality, that would be really 7.5. There we go. So I think that's 7.5. Like that. So what would happen if there were 10 blue? You would have 7.5 purple lightsabers. Depending on the teacher that you have. They might say that there would only be 7 lightsabers, 7 purple lightsabers, because you can't have half a lightsaber, and you can't round up when you're creating things. So there you have it. A little bit of ratio tables with a lot of lightsabers. Hope you enjoyed. Thank you, all you math Padawans out there, for being with me and learning a little bit about ratios and tables. Until next time, have a great day. Oh, don't forget, go and subscribe right down there. Thanks so much. Cheers.